Hello, in this video we're going to do some cluster analysis using the R programming language. Now, up until now we've been using the home equity line of credit data set, but now we're going to use a new data set. And this one here is going to be the IRIS data set. Now let's read this guy in and take a look. So I've read it in as we have before, and you can see it's called iris.csv. And what I do is what I know here is a species of iris. And in this case it could be a setosa, a variscolor, or a virginica. These are three different species of iris, and if you don't know anything about flowers, an iris is a flower. Now we happen to know for each of these guys what is the sepal length, the sepal width, the petal length, and the petal width of each of these flowers. So to cluster, the first thing we're going to do is we got to get rid of this species here, because the clustering algorithm only likes numbers. It doesn't like character variables. So to do this in R, we're going to basically take, this is the we read in all of our data and we dumped them into train. Train is our data. Well, we're going to take train and we're going to dump him into a new variable called new train. Only, if you look, we have 5 columns. We have column 1, 2, 3, 4, 5. Well, we only want to use the numbers. So the numbers are 2, 3, 4, 5. So I'm going to copy columns 2 through 5, and let's just print those guys out. And you can see now all I got is the numbers. Now remember, we've been doing standardizing the data up till now, where we subtract out the standard, or we subtract out the mean and divide by the standard deviation. Well, we can do that using the R programming language. And we do this with the scale command. So coming over here, if I type, so I've got this guy right here, scale new train. So you can see I've already copied it, new train. So I've got new train and he's just fine. He's just exactly the same as train, only we don't have the character variable in there anymore. So we got this guy. Now we're going to take this guy and we are going to scale him. Well, scale really means subtract the mean, divide by the standard deviation. So everybody here should be within the range of plus or minus 3. And if you look at this, this guy's got an average of 0, just like you would expect once you see. And they also all have a standard deviation of 1, although I don't see that printed off on the screen. But they do. So let's just move along and build some clusters. Now, here's some code that I got off of the internet to help you decide how many clusters you want. And the logic behind this is very similar to our scree plot. So I'm just going to copy this code and we're going to run it. Now, my personal favorite way of doing deciding how many clusters is I use a little bit of expert knowledge of the data and some trial and error. I build some clusters, I do some profiles of them, examine them, and decide if I like them. If I like them, that's good enough. There is no real mathematical way, despite what anybody tells you, there is no mathematical method to know if a cluster is good or not. You look at the cluster, and if you like them and they make sense to you and they're useful, then they're right. That's the trick with clustering. You don't have to make these a little bit any more complicated than they are. But I did find this code on the internet. And what you're supposed to do is look for some natural breaks in the data, just like the scree plot. And so things kind of flatten out around the 3 or 4 range, 3 or 4 clusters. So you might be able to have 4 clusters, maybe 3. Because I know that there are already 3 types of species of iris, I'm going to start by assuming that there are 3 clusters. So this is the formula for that. K-means, give it the data, and I want 3 clusters. It's just that simple. And if I do CLS, that's where all my clusters are. I got all sorts of data here, and I could look at these, I could do CLS, $, I don't know, centers. And this tells me the average center point for each of these clusters, and I assume I could look at other things like size if I want. Tell me how many people are in each cluster. So there's some other metrics in there as well. So got 3 clusters. Now what am I going to do now? Well, I could just add the cluster membership to my training data. So remember, my training data looked like this. Let's do this. So my training data, my original data set looked like this. I have setosa, sepal length, blah, blah, blah. Now, this command right here is just going to tack on a cluster to the back of that. And if I print them now, you can see I've got setosa, blah, 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 cluster number 1. So let's take a quick assessment of this, and I can look at the average and break it down by the cluster. So let's take a look at this, and you can see that I have 3 clusters. Cluster number 1, the average sepal length is 50, the average sepal width is 34, 14, and 2. This guy is 58, 26, 43, 14. And this guy is whatever here. And so I could use that if I were to want to bring in, some new flower. I could just calculate the distance from measuring its sepal length, width, petal length, and petal width. I could tell me which cluster it's closest to. But here's something kind of neat. Now remember, I did not do any sort of analysis based upon the when I built these clusters, I just looked at the raw data, and I didn't look at the species of the species of the iris. However, if I do a quick table here, you can see that setosas, every one of them ended up in cluster 1. Most of the Variscolor ended up in cluster number 2, and most of the Virginica ended up in cluster number 3. So even though I didn't try to make the clusters into predictive models, they actually did a pretty good job. Just for fun, we could go back here and rerun this thing. Let's save this real quick. I could rerun this thing and try to make it more clusters. I don't know, let's try 7 clusters. Well, it seems like it breaks off at 4. Let's go 7 clusters. What the heck? Then there seems to be another drop off. Let's do 7 clusters. See what we get. But before that we do that, let's just go up here and let's remove all the objects. Let's start with everything clean again and reload into the data set. So this guy here, if I do miscellaneous, remove all objects, that's just clears out all the memory. And let's clear the console. So we're starting over from scratch. Now we're going to go back over here, and remember we've got 7 clusters. Let's just read everybody back in and just see if this thing was any better. So you can see that if you are a setosa and you're in cluster 1, that's perfect cluster. Variscolor, 2 is mostly a Varus color. 3 is mostly a Varus color. Doesn't look like that really helped out all that much. So, well, never mind. Just, it was worth trying. Sometimes adding a few extra clusters might help. This didn't look like it was all that good. I think 3 was a good magic number for this. So, anyways, so I guess this is clustering using R, or the programming language R. So that's it.